Okay, this video will be designed to teach you about net benefits, areas, etc. So I've already graphed an example here where the demand curve is 100 minus Q, supply curve is P equals Q, and I labeled them marginal benefit and marginal cost. Again, the other words for those would be demand curve or supply curve. Marginal cost and supply are the same thing, demand curve and marginal benefit are the same thing. So let's start how to use these graphs. There's usually two things we might use the demand curve for. One is to get the marginal benefit of something, the additional benefit of the next unit, or the total benefit, okay? How many of the first X units worth? Okay, let's use an example here for Q equals 60. So for Q equals 60, if I'd like to know the marginal benefit of 60, what that means is how much is the 60th worth? Not the first through 59th, okay, but the 60th. To get that, it's the height of the demand curve. So it's this height right here. Let's see. There, the height of the demand curve, which is 100 minus 60 using the demand, using the equation, okay? So 100 minus 60, plug in 60 to the demand curve for Q. 100 minus 60 is 40 bucks. So that is the marginal benefit. Oh, that's not a good idea. That's the marginal benefit of the 60th. Now, we often are asking for, though, what's the total benefit? How much are all 60 worth collectively? Because again, the first one is worth a lot more than the second one, worth more than the third one, etc. That's why our marginal benefit curve slopes down. So to get the total benefit, we need the area underneath the demand curve or the marginal benefit curve. Okay? If you like calculus, it's an integral. Right now, though, let's do it. So the total benefit is going to be all of this area here. Area underneath the marginal benefit between 0 and 60. So it's that shape there. Okay. Let's calculate that area. I will do so. Okay. So let's write it down over here first of all. So the marginal benefit of Q equals 60 was marginal benefit 100 minus plug in 60 equals 40 bucks. Okay, the total benefit, I'll use the area underneath the demand curve. So the area of that thing is 1/2 times the sum of the two parallel sides times the width. Okay, so it's 0.5 times 100 is the height on the left plus 40. Those are the two uneven, the heights of the two uneven sides, times the width, which is 60. Okay, so $4,200 is the total benefit of providing 60 barrels of oil. I'll use barrels of oil in this example. And again, the 60th was only worth 40 bucks. Okay, let's do supply now. It's a very similar process. If we'd like to know the marginal benefit, sorry, marginal cost, let's get rid of these numbers here. Okay, if we know the marginal cost, we do the height of the supply curve at 60, which is this area here. How did I lose that thing? Got it. Okay, height of the supply curve. Let's do that right here. Here's the height of the supply curve. And if you plug this into the supply curve, if you plug 60 to the supply curve, you will get 60, because the equation is P equals Q. The area underneath it reflects the total cost, okay? So the 60th barrel to produce costs producers 60 bucks. That's the opportunity cost. If you want to ask, though, how much do all 60 cost? Well, the first ones are very cheap. That's why the height of the supply curve is so low down here, okay? But if you want to know the cost of all 60, you need to add up the heights of the supply curve from 1 to 60, or a lot more simply, take the area underneath the supply curve between 0 and 60. Again, that's an integral, okay? If you like calculus, I won't use much calculus in this class, though. So the marginal cost of Q equals 60 is, again, 60, just plug it in, P equals Q, $60, put the dollar sign there. And the marginal, the dollar sign here, the total cost of Q equals 60 will be the area underneath that, which in this case is an area of a triangle because it goes, the marginal cost goes to the origin. So area of a triangle is 1/2 times base times height. 0.5 times the base times the height. $1,800. And let's calculate the net benefit of Q equals 60. Net benefit minus cost. Fairly simple in this case. The benefit was $4,200 minus the cost, which was $1,800. And so the net benefit is $2,400. How do we see that graphically? Okay. To identify that, again, it's area underneath the demand curve minus area underneath the supply curve. So it would look like this. If you highlight, here's my area underneath the demand curve, all the way between 0 and 60. Here's my area underneath the supply curve, between 0 and 60. So the green area minus the blue area is the net benefit. You can see the area. So what's left over is, let's see, so the net benefit will be this area here. It'll be the pure green minus the pure blue, okay? So the cross-hatched area, this area down here cancels itself out. So I'm gonna erase those. What's left is the net benefit. It's always an area between a demand curve and between a supply curve, okay? So again, and on the left here, it's positive. When the demand curve lies above the supply curve, then your net benefit is positive. These are positive net benefits, and over here is a negative net benefit. And a very simple word for a negative net benefit is a deadweight loss. I'll show you that now, though, okay? So let's do one thing. So let's talk about deadweight loss. Actually, before we do that, let's do the efficient quantity. And net benefits are maximized at the efficient quantity. That's the definition of the efficient quantity. So I'm going to erase the negative net benefits that were to the right of my intersection. And so the quantity which maximizes net benefits, most of you probably be familiar with, it's where the marginal cost and marginal benefit intersect. Doing some simple algebra, you can figure out that that's at Q equals 50. So let's write that down here. That's the efficient quantity is Q equals 50, where net benefits are maximized. You could also solve for where the marginal cost equals marginal benefit to figure that out, and we'll do that. Let's calculate the net benefits then at the efficient quantity. Okay, it's the area of a triangle. It's again 1/2 times the base times the height. Let's put a dollar sign in here. See if OneNote is smart enough to deal with a dollar sign. I think they are. Yeah, $2,500 is therefore the net benefits of Q equals 50. The net benefits of Q equals 60, as you can see, are 2,400. In other words, they're $100 less. Okay, and the logic for that is if you proceed beyond the point where the marginal benefit exceeds the marginal cost, now the cost of producing exceeds the benefit. Okay, so you're making a barrel of oil which costs, for example, $55, but people are only willing to pay, say, $45 for it. Okay, that's a $10 waste on that barrel, and that contributes to the deadweight loss. All barrels from 50 to 60 have that property where the net benefit is negative. So efficiency says don't produce those. Therefore, how do we measure the deadweight loss? Well, it's the difference in net benefits. Okay, so our equation from our worksheet is, here's the equation for net benefits, sorry, for deadweight loss. So let's write that down. The deadweight loss will always be, no matter what problem I give you, it'll be the maximized net benefits, which in this case is 2,500, minus the net benefits at some other quantity. Okay, in this case, I calculated at Q other equals 60. So in this case, it's $100. where is the deadweight loss graphically? Okay, to do that, I'm going to show you another way that I like to do it. Let's erase this green area here. And as you can see, I've drawn two vertical lines at Q equals 60 because I'm interested in that quantity, in Q equals 50 because that's an intersection of a line. And so to isolate my areas easily, it's nice to have vertical lines at those intersections. Okay, I'm going to put some letters on here. Let's call this area A. I'm going to call this area B. I'm going to call this area C, and this area D. Okay, so I have 4 regions on my my picture. So let's identify what the deadweight loss is. Using our formula, it's again net benefits at Q star. Okay, so net benefits at Q star using my areas are net benefits at Q star. Using areas, it's area underneath the demand curve, A and B, okay, minus area underneath the supply curve, which is B. Okay, what's left over is just A, and that's the green area I had shown before. What's the net benefit at Q sub 60, or Q equals 60? Area underneath the demand curve minus area underneath the supply curve once again. Okay, so area underneath the demand curve is ABD. Okay? In case you can't see that, again, I'll show you again. It's the entire area underneath the demand curve, okay, between 0 and the relevant quantity. So it's all of that area, A, B, and D. The area underneath the supply curve is all of the area underneath the supply curve, all of it. Okay, between 0 and 60 as well. So it is all of this area between 0 and 60, and you stop at 60. So it's all of that area. Okay, as I showed you before, but I'm just showing you a different way to see this. So now it's ABD minus BDC. Okay. Let me erase these. And so the deadweight loss is the difference in these two areas. Net benefits at Q star, A, minus net benefits at Q equals 60. I made a typo. And actually, let's do this calculation. I didn't do it yet. So ABD minus BDC is A minus C. Okay. So the deadweight loss of Q equals 60 is A minus, in parentheses, A minus C. Difference in two net benefits. A minus C, which is equal to A minus A cancels out, negative C, C. Okay, so area C is the deadweight loss, this piece here. And let's calculate it. Okay, it is equal to 1/2 times base times height, 0.5 times the base, which is 60 minus 50, so 10 times the height. The height of that is, I believe, 60 minus 40. Again, if you plug in 60 to the demand curve, you get 40. If you plug in 60 to the supply curve, we got 60, so that difference is 20. And so deadweight loss is $100, as we saw before. I'll do one more example of a deadweight loss of Q equals 0. Okay? In other words, how much net benefit are we missing out on because we're not producing anything in this market? Okay? So this one's fairly easy. It is, again, the deadweight loss is the net benefit at Q equals 50, which is the efficient quantity. So I'll leave it as net benefit at Q star, minus net benefit at Q equals 0. What are these? We calculated net benefit at Q star. It's area A. The net benefit at Q equals 0 is 0. There are no net benefits if you're not producing any oil at all. There's no cost, no benefits. Okay? So it's A minus 0, and therefore that's simply equal to A. In other words, the greatest net benefits possible are producing 50 barrels of oil, which is all of this area A here. If you don't produce anything, then you're missing out on those net benefits. And so A represents the deadweight loss. This is different from the deadweight loss I showed you before. This is a deadweight loss from not doing enough of a good thing. And by a good thing, we mean cost is less than benefit. The blue deadweight loss is the deadweight loss of doing too much of a good thing, okay? Past the point where the cost, past the point where they intersect and the cost starts to exceed the benefit. So you're doing too much of a good thing and now you have cost exceeds benefit or negative net benefits.